Hello and welcome to day 23 of the video journey of daily coding challenges. Let's start today's question. Question 352, data stream as a disjoint interval. Okay, a data stream as a disjoint interval. Given a data stream input of non-negative integers a1 through an, summarize the numbers seen so far as a list of disjoint intervals. List of disjoint intervals. Implement summary ranges class. Summary ranges initializes the object with an empty stream. Void add number adds an integer value to the stream. Get intervals returns a summary of integers in the stream currently as a list of disjoint intervals start to end, where the answer should be sorted by start. If I'm correct, I think there's another question that I did previously, something about intervals as well. It seems like we can reuse some of that logic there. I'm going to link a post, or I'm going to link the video in this as well. Okay, so let's look at the examples. So this is an input of files that are being called in the test, and I'm guessing here are the arguments. So input summary gets called with nothing, add number 1, get intervals. Okay, so basically summary ranges add number, get intervals, add number, get intervals, add number, get intervals, and so on. Initialize, add number, get intervals, add, get, add, get, and initialize gets nothing, add gets nothing. But the first time that we're getting the intervals, we get a 1, 1. The second time we get a 1, 3. Third time 1, 3, 7. And then 1, 3, 7, 7. So this 2 linked these two intervals together. And as a result, we get, this is the one that we care about, the final one, 1, 3, 6, 7. 1, 3, 6, 7. 1, 2, 3, 6, 7. This is very similar to the previous one. I'm going to link it up here on the top right, so keep an eye out for that. Let's start implementing. This is how I would think about the problem. The constraints here, let's see, does it have to be sorted? It seems like the result has to be sorted by start, right? Did I read that somewhere? Yes, it is sorted by start. Similarly, in the previous question, it required it to be sorted by start. So on the initialization, let's have a empty array nums where we're going to keep our intervals. Let's call it intervals. We're going to be doing the process of creating our result at time of adding num. So here the return value is going to be intervals. All of the heavy lifting is going to be in this function. And it's pretty simple, I think, what we have to do. We have to create, say that we have at this point an interval say that we're in this point of the test where we have 3 disjoint intervals. I believe they were 1, 3, and 7. And these are all in they're all sorted by start. and they're not overlapping. That was the question. Non-overlapping intervals, the one that I'm referring to. Here, they're non-overlapping, and they're sorted by start. If we have this data structure, which could easily be accomplished by sorting, calling self.intervals.sort, which will do some bubble sort to quickly put the current interval that we're trying to add into the right position. After we have this data structure, it would be pretty easy to kind of, like, let's say that we have an interval like this, or even like this, right? We could check that the difference between this interval here and this interval here is greater than or equal to -1, right? Greater than or equal to, okay, hold on 1 second. What is the condition here by which we would join these two? The condition here is that current end we have is 1 and next start is equal to 3. And if next start minus cur end is greater or equal to -1, then join them. Am I right? In this case, the difference would be, no, I'm not right. It would be current end minus next start. If current end 1 minus next start is equal to -1, let's say in this case, current end minus next start is equal to 1, right? So we would, why am I having such a difficult time with this? The difference between these two has to be greater than -1. This minus this has to be greater than -1. That's all. Yeah, so I'm correct. So this is the condition under which we will join these two intervals, and the joining is done just by eliminating this part of the array, this element from the array, and changing the current array's end to the next array's end. That's it. So, okay, in this case, when array 2 and 2 is added, let's say that this is the argument, the first step that we would take is add it into the sorted list, and the sort would take only on if we're constantly sorting as we're adding numbers. Once we've sorted the array, we're looking at the current interval and the next interval and applying this constraint. And in the case that this constraint proves to be true, we save this value 2 in a variable, delete it, and then update this current interval again. And while this constraint or this condition keeps true, we keep on doing it. So we see that 2 minus 3 is going to be -1, and our condition meets. So we save this condition, we save this variable, delete it, and append it. modified. Okay, so pretty standard stuff. Let's see if we have some edge cases. I think that if len of value is less than 2, right? Then we can just return. Well, we're returning either way, but sorry, not of self value, self. Let's do this. Intervals length is equal to len self intervals. Oof, what was that? Sorry. Then we do this condition. If it's, what is going on? Intervals len is greater or equal to 2, then return. Then we do self intervals append our new interval that has not yet been populated. Then we will do sorting here. Let's see. For sake of, yeah, let's do this first and let's see if this works. We're going to do a bubble sort, and a bubble sort see how would bubble. Okay, a bubble sort, if we're appending it to the end, then we have to start from the end to put it in the correct space. So current is going to be intervals len minus 1, and while current is greater than 0, essentially we will say that the previous is equal to the current minus 1. Previous is equal to the current. Should this be? Oh, no, this is correct. Previous will have a chance to be 0. Previous gets a current, and if self intervals previous start happens to be larger than self intervals current start, then we say temp is equal to the previous. Previous is equal to current, and current is equal to temp. So we've just went ahead and placed our new interval that we've appended to the and. Let me do this one more time. 1, 1. This was 3 and 3, 3 and 7 and 7 before. Now it is, after the append, it will be another 2, 2. Sweet. Now, after this sort, it should be same thing, but the 2 and the 2 goes here. And now we just have to apply our merging algorithm, right? So in the merging algorithm, we have a current interval index. Let's say cur I and dx is going to be equal to 0, and while current I and dx is less than interval, no. Okay, so in this case, we shouldn't be using a constant because we are going to be potentially modifying the length of the list of intervals. So here we'll actually be using the actual self intervals value. It's going to be calculating it each time. And now that we have that, let's say that the next is going to be current index plus 1, and yeah, current interval is going to be just equal to self intervals index, just for ease of use. And now our, did I delete the thing that I had? Yeah, I did delete it. Our condition. Okay. Our condition is such that if current end, okay, let's do this. While, because we could potentially be comparing these two many times. First, we'll compare these two, and while these conditions meet, we will be doing the process and then doing it again potentially for the next one. So while current interval end minus self intervals at next start is greater or equal to -1. Why is this so unintuitive? What if I was to do it more like mathematically? Let's say the current interval can be one less, at most one less than. So okay, better yet, let's do it even more intuitively. The f can be at most one less than the s. In this case, the f is this, and the s, because the f is this and the s is this. How do I put that into code? And it's always better to say these things out loud and learn how to actually implement it in writing rather than just memorizing or finding some condition that works, like what I did here. So let's do that. If f can be at most one less than the current. One less than the current. So self intervals next of start what would be another way to say this? F can be at most. Why are these conditions so hard? Plus 1. Oh, okay, I know how to do this. Has to be bigger than 0. So imagine that I'm shifting this 1 more to the right, so this becomes a 2, and I'm saying that 2 minus 2 has to be 2 minus 2 has to be greater than 0 for them to meet, because if they are too far apart, meaning that it would be more than 0, then these two would not be next to each other. So, which, okay, whatever. It translates to this. It's just easier to write. So while current is equal, then we say that the self nums. And now we actually have to go ahead and update current interval. Let's get rid of this completely. I don't need to have. Let's be accessing it ad hoc. So current interval end is equal to this guy's end, and then we're doing self intervals pop next. So what would happen here is it would pick up these two as current and next. It would pass this condition of being of 1 minus 2 being equal to -1. It would change this to a 2, and it would pop this from the array. Next iteration does the same thing because this while condition happens to be true. It's going to compare these. It's going to take this number, move this to here, and then completely remove this element. Sweet. And so after we've done that, we now have we now have this array, which is what we need. So this honestly should work. Let's see if this works. First try? Nope. Never first try. Removing this thing here. Wrong answer. No. So what's happening is I'm not returning anything. Somewhere. Well, no, not just somewhere. It's just that I'm not returning anything. So intervals is never being appended to? That doesn't make sense. I'm obviously appending to the intervals. Am I returning something different? I've had that happen a couple of times that I return a different value. No. Okay. I have these while statements, but I might not be. Yes, I am failing to do. So used to using for loops where this is basically written in them that I forget to put these here sometimes. So in a while loop, there's no statement that gets executed each time. So I have to do this manually. And for this one, for this while loop, I'm not changing anything because in the case that an element does get removed from the index, the next would still be pointing to the next variable. And let's see, are we getting something? No, still nothing. I'm worried that okay, let's always helps to talk through these. We initialize an empty list intervals. Once we do that, the next call is to add a number. The number that we're adding is 1. Add number gets called with 1. We calculate interval's length, which is currently at 0. And and we return it, which is absurd, because why would I be returning it before appending anything to it? Let's append first. Let's append first, and then check if we have to do any of this logic here. Yeah. Okay. Sweet. Okay. We're getting somewhere at least. Index out of range. Before we do index out of range, that means that in the sorting somewhere here, I am messing up. Would this be a current intervals length minus 1 is the current, unless I'm calculating this length before, and I'm not. Okay, intervals. Well, what would happen when I'm at, let's say, at 1? At 1, previous, when current is equal to 1, when current is equal to 1, I am, previous is equal to 0, so how could this be out of range? Smaller or equal to 1, then remove. So if the list of indices only contains one element, then return, because we don't have to do any sorting. In the case that it's 2, for example, current is first going to be equal to 2, interval's length is going to be equal to 2, current is going to be equal to 1. If current is bigger than 0, previous is equal to 0. If self intervals, to which we just added the previous, prev is equal to 0 and current is equal to 1. We say that temp, okay, time to print these things, previous and current. That's right. std out 0, 1, previous, current, and for some reason 1, 2. So it's not breaking on the first time that we're adding a value. Let's see what kind of values we're adding. Print value. The first time we're adding, what test case is this? 3 and 3? 3, 0, 1. 3, 0, 1. You know what? I didn't want to do this because I'm scared that I'm going to somehow use up too much time doing it the default way, and I wanted to implement the bubble sort myself, but interval sort should work just fine. List index out of range once again. List intervals, which is just an array, is out of range. Intervals holds all of our sorted intervals. Let's get rid of this for now. Let's see, the current index is set to 0, and length of the intervals is just the length. Current interval is set to 0. While Okay, so this should definitely be something different because, well, for one, I am never going to be in a situation where current is looking at the next, right? Or current is looking at the last element. Sorry, in this case, current would be looking at the last element, but I don't want it to look at the last element. I want it to look to the second to last element. If this doesn't work, then I'm thinking that maybe in this array here, next somehow is exceeding the length as well. So what if I say that next is smaller than len of self intervals as well, and awesome. Okay, submit this. Okay, what about here? So okay, the problem here was that next was getting ahead and turning over to the end of the array before this while loop was ever executing. So keep in mind here, I guess, that also you could, inside of this while loop, looking at the potential intervals to merge, you could also exceed the length of the initial array. What I'm looking for here is, I just saw it 6, 6, 6, 8, 6. So it merged. Wait. 6, 6, 0, 4, 8. 6, 6, 0, 4, 8. And then after the 0, 4, the 7 gets there. So we merge the 7. And then 6 again. And we do nothing there. And then 4 again, nothing there. And then 5, but nothing happens to the 4, 8. Oh, the 8 is lost. The 8 is lost after we add the 7. The 8 is lost after we add the 7. How about, huh? How about we add a set? So if this works, first of all, we don't need this anymore. Solution becomes a little bit more manageable. I want to do something here. Self s is equal to set. And I'm going to say that if value in self s return, and then self s and value. Yeah. The problem there was that we were, oh, look, 95. The problem there is that we were adding value 7 to the array multiple times, and it was overriding, it was overriding one of the existing intervals. For example, like when we had the 4, 8 there, it was overriding the last element of the 4, 8 interval, or the 6, 8 interval. So, okay, 95 is not so bad. I would say that this is actually probably better than most. In terms of memory, we're still lacking, but 19 milliseconds is not a big difference from 17. Yeah, I would say that this is the solution to go with. Linking the question that I did earlier, very similar to this one, basically consisting exactly re-implementing this logic in a previous question, linking that in this video as well. Thank you for watching.